I still vividly remember struggling with this particular problem back when I was preparing for the JEE in 2016. At first glance, it seemed like a straightforward trigonometry question. Just find the maximum and minimum value of a certain expression. Easy, right? But the moment I started working on it, I realized just how deceptive it was. Recently, while revisiting some old math problems, I stumbled upon this same question again, and to my surprise, I discovered that it originally appeared in one of the Chinese Mathematical Olympiads in 1997. That instantly made sense. This isn't your typical textbook problem. It is one of those beautifully crafted questions that look simple but require a deep, clever insight to crack. What is even more fascinating is that the solution doesn't involve anything beyond basic trigonometry. No advanced tricks, just the right idea at the right time, and once you see it, everything falls into the place. So before you dive into the solution, I strongly encourage you to pause the video and give it an honest try. Trust me, this is the kind of problem that really sharpens your thinking, and if you do figure it out, you will experience that incredible aha moment that makes math so rewarding. So with all of that, let us dive into the solution and make sure you give this problem a try. It is a beautiful question. It is a very beautiful question and you will enjoy solving it. So it is given that x, y, z are real numbers and x is greater than or is equal to, y is greater than or equal to, z is greater than or equal to pi upon 12 such that x plus y plus z is equals to pi by 2. And now you have to find out the maximum and minimum values of cos x, sin y and cos z. So the moment you see this expression, it looks very weird. So you have a cos term in x, sin term in y, and again a cosine term in z. So it's nothing symmetric, and there is nothing that we can clearly see about this question when you encounter it. So let us do one thing. So let us denote this particular quantity as p. Now you have to find out the maximum and minimum values of the product p. Alright, so let us write p as half cos x multiplied by 2 sin y cos z. 2 sin y cos z is simply sin y plus z plus sin y minus z. Alright, so from this particular inequality that is given in the question, y is greater than or equal to z, therefore y minus z is greater than or equal to 0. Alright, so therefore this sign is greater than or is equal to 0. So therefore this whole quantity is greater than or equal to sin y plus z. So this is greater than or equal to 0. So therefore this whole quantity is greater than or equal to sin of y plus z. So now p is greater than or equal to half cos x and sin of y plus z. But from this particular relation, we know that y plus z is simply pi by 2 minus x, and sin pi by 2 minus x is cos x. So this is greater than or equals to half cos square x. So when we are writing this particular inequality, we are assuming that y is equal to z. So we are making this particular quantity 0. So we are assuming y is equals to z. Alright. So now, so x plus, since y is equal to z, we get x plus 2y is equals to pi upon 2. From here we can see that p is greater than this particular quantity. So p is also greater than the minimum value of this particular quantity. So we have to find out the minimum value of cos square x. Since x lies in the first quadrant, so the minimum value of cos square x will be obtained for the maximum value of x. Here we will get the minimum value for cos square x. So x has to be maximum. So in order to make x maximum, we have to minimize y. So the minimum value that y can take is pi by 12. So x plus 2 pi by 12 is pi by 6 is equals to pi by 2. X is equals to 3 pi by 6 minus pi by 6, that is simply pi by 3. Therefore, x is equals to pi by 3 will give you the minimum value of p. So p, minimum value of p is equals to half into cos square 60. Cos square 60 is simply 1 upon 2. So therefore, this minimum value of p is 1 upon 8. And this minimum value is achieved when x is equals to pi by 3 and y is equals to z is equals to pi upon 12. So now we have figured out the minimum value of p. Now let us go ahead and find out the maximum value of p. So p is equals to, again, cos x sin y cos z. Now this p can be written as half cos z times 2 cos x sin y. 2 cos x sin y can be written as sin x plus y minus sin x minus y. So sin x plus y is simply sin x cos y plus cos x sin y. And when you subtract it from sin x minus y, you will end up getting this particular thing. Again, with the similar logic, we have x greater than or equal to y from here. Alright. So therefore, x minus y greater than or equal to 0. And since we are subtracting sin of x minus y, so okay, from here we can write sin of x minus y greater than or equal to 0. And since we are subtracting some positive quantity, sin of x minus y, from this whole thing, so you will get, so this, and since we are subtracting some non-negative quantity from sin of x plus y, this whole quantity will be less than or equals to sin of x plus y. Therefore, p is less than or equals to half cos z multiplied by sin of x plus y. But x plus y is simply pi by 2 minus cos z from here. Alright, pi by 2 minus z. Alright, p less than or equals to half cos z, and sin pi by 2 minus z is simply cos z. So this is half cos square z. And when we are making this particular approximation, we made x is equals to y. So we have x is equal to y. Since x plus y plus z is equal to pi by 2 and x is equal to y, this can be written as 2x plus z is equals to pi by 2. Alright. Since p is less than or equals to this particular quantity, p should be less than or equal to the maximum value of this particular quantity. Alright. So cos z is maximum in the first quadrant when z is minimum. So we have to minimize z. Alright. So what is the minimum value z can take? It is pi by 12. From here we can say it is pi by 12. So 2x plus pi by 12 is equals to pi by 2. So x is equals to, this is 5 pi by 12, sorry 6 pi by 12 minus pi by 12 is 5 pi by 12. So 5 pi by 24, x is equals to 5 pi by 24 and z is equals to pi by 12. Therefore, max of p is equals to half cos square pi by 12. Alright, cos pi by 12 is cos square pi by 12. We have to find out cos square pi by 12. Half into cos square theta is simply 1 plus cos 2 theta by 2. So this is 1 plus cos 2 theta is 2 pi by 12, which is pi by 6 divided by 2. Alright. So cos pi by 6 is root 3 by 2. Therefore, this value will be simply 1 by 4 times 1 plus root 3 upon 2. So this is the maximum value of P. Maximum value of P is this particular quantity, and this happens when x is equals to y is equals to 5 pi upon 24 and z is equals to pi upon 12. So this can be a multiple correct answer question in your JEE advanced exam. They might ask you to find the maximum value, minimum value, and the conditions on x, y, and z when this becomes maximum and minimum respectively, these conditions. All right. So what do you really gain by solving questions like this? First, if a question like this or a variant of it shows up in the JEE, you will be prepared to tackle it and score those valuable marks. Second, it is like planting a new idea in your mind, training your brain to think in the right direction when you face similar problems in future. Third, you will also get to appreciate how beautifully basic concepts can be used to solve complex problems. That kind of insight really deepens your understanding of the subject. And with that, we have come to the end of this video. Thank you so much for watching. If you enjoyed this content, please give the video a like, share it with your friends, and subscribe the channel for more problem solving techniques and advanced math insights. If you are interested in solving more such intriguing problems, leave a comment below. I'd love to hear from you. Also check out the other videos on the channel and do not forget to join my Telegram group using the link in the description. Thank you.